All right, so I am going to talk fast. I will try not to, and I will fail, and I am sorry in advance. This is a partial taxonomy of test unreliability. I really need a snappier title. I work at the UCSF library, that's the University of California in San Francisco. We are not hiring technologists right now, but if you want to come and be a data science librarian or something, you should really come talk to me. I do a lot of work on Node Core, and I also have been writing an ever-expanding rock opera about a steakhouse for over a decade. In fact, when we were supposed to have walk-up music, and it got nixed because the AV, there wasn't enough connections or something. So I'm going to see if this works. All right, cool. That feels good. Thank you. But unfortunately, I didn't come up here to play excerpts of my rock opera. I came up here mostly to talk about Node. A few disclaimers, though. They're going to be pretty light speed. First of all, the views expressed are my own and not necessarily those of my employer. Everyone's heard that one before. Also, the views expressed are my own and not necessarily those of Node. There's like 100 some odd other people besides me who have the commit bit on the core repository. And there's 18 other people, well, 17 right now, soon to be 18 other people on the technical steering committee. And thankfully, we all don't agree. We all don't see everything the same way. So with that out of the way, back to Node. I've done a lot of work on the tests in Node Core over the last 4-ish years, and a lot of that work has been fixing what we in the project call flaky tests, but a better word for them is unreliable. Unfortunately, we started calling them flaky and will probably never stop. But they're unreliable tests. And what that means is these are tests that succeed like 99% of the time, but then fail at unpredictable times. And that's kind of, I don't know, I'm trying to capture that emotion with this picture of a test. I love tests, but it's letting me down about 1% of the time. So if you have like 3 tests in your test suite that fail about 1% of the time, and you have, as Node does the last time I counted, 33 different platforms in your CI, which, Lori, wherever you are, that's continuous integration, in your CI server. Oh, there you are, hey. Right, the math, 33 times, 3, 99% of the time. So most of the time, your test suite will fail if you have that, or at least that's what I'm going to say here. So we just did a small amount of probability of probably incorrect arithmetic and statistics. So. And there were some cute puppy faces. So now let's just pretend that I've gone from that small bit of, like I said, probably incorrect arithmetic and statistics, and I've done a smooth transition into science. Or for those of you who, like me, grew up in the 1980s, science! Specifically, biological taxonomy. So just, whoa, hey, pretend that just blew your mind with that smooth transition. Biological taxonomy is, as it says on the Wikipedia excerpt here, the science of defining and naming groups of biological organisms on the basis of shared characteristics. Since we're at DinosaurJS, here's a taxonomy of dinosaurs that shows their evolutionary relationship. Roughly speaking, that's what's called a phylogenetic taxonomy. Or maybe not. I don't know what I'm talking about, so just don't at me. But the dominant system of biological taxonomy is called Linnaean taxonomy. It's named for Swedish botanist Carl Linnaeus, who devised a lot of the things we still use to this day, like the naming conventions that are used in taxonomies. And then there's this person who has their own unique contribution to taxonomy. Raise your hand if you know who this person is. Yeah, that's good. His name is JD, and he's responsible for literally everything that anyone knows at all about the taxonomy of oclopanids. So, like, literally, no other person on the planet knows anything at all about the taxonomy of oclopanids unless they learned it from him. So that's super impressive, although you are absolutely correct to be wondering, what are oclopanids? Oclopanids are the name that he made up for those plastic things that seal bread bags. He's done a whole taxonomy for them. He's done a whole taxonomy for them. And as you can see from this diagram of oclopanid anatomy, he did not come to play. He's got like hundreds of species of these things or something, like all cataloged very carefully. Go to HORG.com to check out his work. It's actually cited in a medical paper because of a case study of someone who swallowed one of these things and the surgery they had to do to remove it. And that's actually true, honest to God. Anyway, so I figured that if that can happen for like the little plastic things that seal bread bags, and I've been doing all this work on flaky tests in Node, I should be able to come up with something, for the taxonomy of flaky tests. Why not? So here we go. Let me just do myself a little quick favor here because my eyesight's terrible. There we go. Okay, great. So, of course, I'm not the first person to ever classify software defects into a taxonomy, but much to my surprise, I think this specific idea is actually somewhat novel. I did a literature search, and I will remind you at this point that I work at an academic library, and the bug taxonomies I found all had different goals than this. They include things like syntax errors, and, that's not a cause of a test that's going to fail once in a while. That's like a defect that's going to cause a test to fail all the time. So of course, there's some overlap between those, the contents of those taxonomies that I found and the contents of a taxonomy like this. But I couldn't find a relevant existing taxonomy. So if anyone knows of one, I would be very grateful if you could tell me about it. I couldn't find one. So I'm also going to wedge in one tiny piece of information, potentially useful information before we continue. So if you only take one thing from this talk, let it be that you really should try to take more than one thing from a talk. But if you only take two things from this talk, let the second one be this. To deal with these things, get a job in your CI server that will run the test over and over and over again on any platform. Do it in parallel, do it sequentially, because the situations that need to be created to cause these tests to fail vary a lot, and you're going to want to be able to reliably determine if you've actually solved these problems or not. And it's maddening when the thing only fails 1 out of 10,000 runs. How are you going to determine if you actually solve the problem? Well, if you can reliably reproduce it by running 50 copies of them at the same time so resource starvation happens, and that's the cause of your problem. Or maybe it's actually that there's the opposite of resource starvation and a race condition is triggered, but only when there's a ton of memory available, that kind of thing. Okay, I'm done. I have no idea if I said everything in my notes. That's okay. I probably skipped a few super golden jokes. Next time. Okay, so let's get started. Race condition. So this is the good old-fashioned race condition. It's just when you have two things that are stepping on each other's toes. For example, two things that are writing to the same file at the same time. You don't know which one's going to finish first, so you can't correctly 100% of the time determine what the contents of the file will be. So what's wrong with this code? We write to a file, then in the write file callback, we read from the file, then in the read file callback, we expect to get the data that we wrote. And the answer is that there's nothing wrong with this code. It's totally fine. But if you wrap it in a for loop like this, then you have two problems. The big one is that this code snippet now obscures my Twitter handle in the lower left-hand corner of this slide, lower right-hand corner of this slide. That's a big problem. But the smaller problem that's more relevant to the topic of this talk is that you now have 100 things writing to different asynchronous things all writing to the same file. This is going to fail pretty much 100% of the time. Race conditions in the wild are fail less frequently and therefore harder to find. The solution is probably obvious. Just like we're writing different data every time, you write to a different file every time. Okay, so next up is the magic number. So here's something based on an actual example from Node core tests, as are all of the examples in this talk. So you do something asynchronous, probably recursive as well, and then after a little bit, you check that things got garbage collected as expected. The problem is that what is that 100 doing in that for loop? That kind of makes assumptions about the environment you're running in, that you're not memory constrained or you are memory constrained or whatever. And so maybe this test will work on some platforms under some situations and not on others. That's not cool. It'll be hard to debug. Those are both things that suck. And so instead, what you want to do is find a way to do the thing over and over again until the condition you're looking for happens. Hopefully it happens a lot sooner than 100 iterations. But if it doesn't, and it just keeps going and going and going, you want the test to fail because the test runner times out. That's a whole lot better than the magic number, because if the test runner's timing out a lot on a certain platform, you can tweak the timeout for the test runner and just give your tests more time to run. If you have magic numbers sprinkled throughout your tests, and they're all different, you're kind of screwed. So you're a really clever audience, I can tell, and you might be thinking that this is a list and not a taxonomy. You might also be thinking, a magic number is actually like a special case of a race condition. In many cases at least, it's just a special case because, you're hoping that something happens before the magic number is up or whatever. So really, it's really like this, and boom, now we have a taxonomy. So next up is the arbitrary, usually long timeout. So what's wrong with this code besides that there's a little piece of my cursor caught in the screenshot there? Just, not my best work. Okay, so you don't know how busy or low resource or high resource the test machine will be. So, the set timeout after 1 second, 1,000 milliseconds. This test could totally fail when there's no bug at all. And that's not what you want in a test, right? So as with the previous example, the solution is to use events or callbacks or something like that instead of what we have here, which is the timeout. And you may be thinking, hey, long timeout is just a special case of magic number, 1,000 milliseconds, where 1,000 is the magic number. And that would be right. So next, I have no idea how I'm doing on time. I forgot to start my timer, but that's okay. Next, let's talk about deadlocks. So deadlocks actually aren't that common in JavaScript, but they do happen, especially if you're dealing with web workers, like Jana's talk was, or if you're dealing with worker threads in Node. So the way a deadlock basically works is, process one or process A, so A at the top, which represents a process or a thread or something. It has resource 1 locked, and it's trying to grab resource 2 so it can continue, and it's waiting for that. Meanwhile, process or thread or something B has resource 2 locked, and it's trying to grab resource 1. So in a naive implementation, they'll both just wait forever. And that's not cool. So back to our taxonomy, a deadlock is also a race condition, right? If either A or B both, gets both resources before the other, then everything's cool. But if one gets one resource and the other gets the other resource, you're in trouble. So let's put deadlock under race condition like this. This next one, I didn't know what to call. So I started with ones that kind of have their obvious names or well-established, names. Other taxonomies talk about race conditions and deadlocks. This next one I didn't know what to call, so it's too much stuff going on or something like that. So we'll just call it TMSGO. So let's say you have a test that looks like this and everything is fine. Cool. Then you add a feature, you have to add a bunch more tests, and someone does this. Ignore the red curly Q. That's just something telling us all that ... is not valid JavaScript. Maybe it would be okay if I used the ellipsis character. I don't know. Anyway, so now our tests start timing out on some platforms, but only sometimes because you're launching too many freaking processes. So this is also a race condition, right? So, okay, this says click here to add speaker notes. So I guess I forgot to add speaker notes for this slide. But the point is, yes, indeed, TMSGO is a race condition. All right, so in fact, any slow test that times out is a more generalized form of a race condition. All right, so next up from the annals of works on my machine shrug is, honey, I tripped the firewall. Which that's too long, so let's just call it firewall, but that's too boring, so let's add an exclamation point. This is when you make 500 HTTP requests in a row to a web server you've set up for testing, and the operating system decides to throttle things, causing your test to fail, but of course only on machines with the firewall configured that way, which doesn't happen to be your developer machine, but happens to be the next person's developer machine or whatever. Anyway, often it's only sometimes, it's totally maddening, which is the whole point of going over these sources of test unreliability. So, not moving anything here, just kind of changing the text size to make a little space. If you're sometimes tripping a firewall through network usage and sometimes not, that sure sounds like a race condition. Booyah. That booyah had a silent neutral face emoji after it. I don't know how to say that, but all right. So next up, we create a server and tell the operating system to give us any old port, any old network port, and we retrieve that's what the 0 is in listen in Node. That says operating system, please give me an available port. I don't care what it is. So we retrieve the port and then run some tests, but we increment to get additional ports. And this happens in a bunch of places in Node.js, or used to happen, probably kind of still does, in a bunch of places in Node tests, because the cluster module, that's how it works. It increments ports as you add workers. So the problem is that, of course, ports are finite. Once you get up to 65,000 whatever, you're out of ports, you're done, it's over. So if the operating system happens to assign you a high enough port number to start with, you'll exceed the range of valid ports and your test will fail. So the real problem here is what to call this kind of problem. Is it a range error? Is it an overflow error? Is it an off by one error even? We're gonna go with range overflow by one error. Just kidding, kind of. Range overflow is fine. It doesn't have to be by 1, it can be by 2 or 5, it doesn't matter. Anyway, this is obviously a race condition 2, right? I mean, no, wrong. It's not a race condition. Pay attention. We're going to put this one off to the side, kind of by itself, like bacteria in biological taxonomy. And then we're going to add a hypothetical common ancestor of Eradimflakeus. So we haven't found the fossilized evidence of it. You people working on paleontological data, please get on that. Anyway, so that's 8 causes of unreliable tests and one made-up thing at the top there. So the original and much shorter version of this talk that I gave at WaffleJS in San Francisco had 10 causes in the title, and I got stuck here. But fortunately, Max Goodman, who helps organize WaffleJS, mentioned 2 more causes when I proposed my talk in the first place. So I straight up stole his. First, there's tests that affect global state. This is kind of side effect. So global state shenanigans, which kind of sounds like a basketball team. I think they have a pretty good shot at the championship this year, to be honest, as long as they can get past the fighting growlbacks. Anyway, yes, the global state shenanigans. So I'm glad that worked. I wasn't sure that I wasn't sure that this was going to work in Denver. That's the logo for the Golden State Warriors, and of course, I had to reconfigure the letters, and there's no B in Golden State Warriors, so it had to be global state rather than global state. Anyway, cool. Glad it worked. Anyway. So next, and in addition to global state shenanigans, next there's tests that sometimes run concurrently, even though they cannot successfully run concurrently. We'll call that not currently, because we are seriously running out of ideas. Anyway, these are both clearly race conditions, but a special kind of race condition. It's kind of like babies having babies, but it's more like tests affecting other tests. It's really just side effects, but I couldn't think of that last night. So now we draw a wonky line because there's not enough space, and by slide 76, we're kind of running out of enthusiasm to make it neat, and figure there's a really good chance we're going to cut this slide anyway. So let's talk about conclusions we can draw from this exercise. First, whatever kind of unreliable test you have, the cause is going to be a race condition, probably. Second, nothing really. It's just that last one. I know the numbering was kind of misleading, and I'm really sorry about that. But a quick bonus thing I didn't really talk about, but maybe Jasmine will ask me about it in the Q&A, so I can blather about it for a minute or two. Windows. I'm not dissing Windows here, but if 90% of your contributors develop on MacBooks and Linux, but 60% of your users are on Windows, and I don't know what the actual numbers are, but I swear to you, that's what it feels like on Node. It feels like everyone who builds Node uses Linux and Mac OS, except for 4 people, and more than half of it, especially if you look at global statistics, everybody's running Node on Windows. That might actually cause some issues. So now imagine how long it takes to debug those issues when you either don't have a Windows system available conveniently, or you're incompetent to use Windows, which both of those descriptions have applied to me at different times, at the same time, in fact. So it takes a really, really long time to debug those issues. So Windows issues are particularly problematic for us in Node, so I would like to invite Windows developers to please get involved in Node Core. I will do anything I can to make it easier for you within reason. Buy you a pizza, buy you a coffee, I don't know, something. I just, help us, please, because I suck at Windows. Okay, all right, back to the amazing taxonomy. Now, I could look at this slide all day. But if there's any mercy in the heavens, my time must be nearly up or something. And we can unplug my laptop so you don't have to look at it just because I'm looking at it. But anyway, thanks for your time and attention. It means a lot to me, and you're all awesome. I wish I could actually walk out there and thank each and every one of you. And actually, it looks like maybe I'll have time to do that. I just I thank you, then I thank you, then I thank you. And you get the idea. But anyway, thanks. And did I miss anything in this slide that I'll talk to you? I'm going to walk over the end. No, that's it. Thanks.
Thank you so much.
You want to tell us a little bit about Windows?
Do I what? Do I want to talk about Windows?
Yes.
I just did.
Okay. There's no more detail, or is that it?
I mean, the people who build Node.js, compared to the people who use Node.js, Windows is underrepresented, and that is something I would like to fix. Fix some other way than becoming a Windows developer myself, but I might have, I might do it. Not because I don't like Windows, just I'm comfortable where I am, and so, yeah.
Gotcha.
Yeah, you work at Microsoft, don't you?
Yeah, I use Windows primarily. I do have a MacBook right now, but I am a Windows person.
Yeah.
So when do you know how you have a flaky test and not a real failure?
I mean, so the way I know is, someone will open a pull request, we'll run continuous integration on pull request. There'll be one or more failures. Someone will come along and rerun continuous integration, and everything passes. Sometimes so I kind of focused on problems with the tests themselves. Of course, sometimes it is in fact a bug in the code. The race condition doesn't have to be in the test. The race condition can be in the code. And also something I left out is a lot of times the problem is in CI. Like just weird configuration issues or whatever. The vexing thing is you never really know until you start digging into it, and you can burn through a lot of time doing that. But it's totally worth it once you solve the problem. You're just kind of like, yes, neat answer.
So how much time can a project of Node.js's size lose to erratus flakius?
I mean, I'd say that I've lost the last 4 years. And there's a couple other people who focus on the flaky test too. When Node, was first being developed, by Ryan Dahl and others, there were tests, but it wasn't test-driven development by any means. There certainly was, it was only like a few years ago that we started getting nightly coverage reports so that we have an idea of what's covered and what's not covered. I forgot what's the question here. How much time can we lose? Yeah. So just like so I joined around the time of the IOJS fork, which was there was a dispute over the governance of the Node project, a dispute between a lot of the prolific contributors at the time and the corporate steward of the project. Eventually that issue was resolved, and IOJS basically became Node.js. They merged back together. But I joined around the time of the IOJS fork, which was in 2015, if I remember correctly. And like the message that like the fork was trying to send was, we want more contributors, come and help. And I was a Node.js user, and it's like, yeah, sure, I'll take a look at that. And so I did some documentation fixes or stuff, added some missing commas or whatever to some text, which is a great way to just get started, figure out the process if you're a grammar nerd. And what became quickly apparent was that the tests were just a dumpster fire at the time. And so, I figured, well, I can I can go through and figure out what's wrong with each test one by one. That'll just be super unbelievably tedious and a time sinkhole, but it's value I can add to the project. And it was super tedious and a sinkhole for time, and it was super valuable. And kind of much to my surprise, not too long after spending, I don't know, probably 18 months to get the continuous integration to occasionally be green, to occasionally be passing, because it never passed when I joined the project. Never. It was red, and it was failing every time, and people would look at the failures and say, oh yeah, those are failures that we know about. You can just merge the code, which then just meant that more failures just piled up, right? Because anyway, yeah. So after 18 months of just basically working on tests, and I did one or two things in the actual executable, but not a whole lot. It was oh, I got invited to be on the technical steering committee, which was a nice sort of way to express that they valued that the tests were not broken. And actually, when Node 4 was released, which the thing I remember most about Node.js 4.0 is everybody saying, "What is wrong with you? Can't you count?" Because what happened is we went from Node.js 0.12 to Node.js 4.0, and who has no idea why that happened? I mean, I would hope a lot of people, because why would you care? But the answer is that the IOJS fork happened, and IOJS is like, we're not releasing 0. whatever, we're releasing 1.0, and now we're releasing 2.0, now we're releasing 3.0. And so as we released 4.0, so when 4.0 came around, we didn't want to go back to 1.0, because if you type node-v and you get 1.0, you don't know if you're running IOJS or if you're running, this other version of Node. So integers are free, like we're not going to run out of them, so just use 4. But people got mad. I mean, anyway, the other thing I remember about it is that the sort of the San Francisco folks who were involved at the time, because I live in San Francisco, we had a party to celebrate the merger and everything. There were maybe 8 or 12 of us tops. Anyway, the party was in my basement. My wife has a tiki bar, and that's where the in the basement. That's where the party was. And I just remember that the palpable relief in the room that the tests were now only mostly unreliable instead of completely useless was just was a really nice validation. So I'm just talking about how cool it is to be validated, which just shows how insecure I really am. I have to work on my self-esteem issues, clearly.
So one last question. Out of that diagram that you showed, what's the most common thing that you've seen?
Oh God, I have to look at the diagram. Let me think about that for a second. Oh, okay. So in Node, the most common thing is the arbitrary long timeout, because everybody who writes a test for the first time and has not most of the people who are writing tests in Node have not gone back and fixed other people's broken tests or their own broken tests, and so everybody thinks that the thing to do is oh, well, I have this event and I need to make sure that it happens, but I don't know how far in the future it's going to happen. But if I give it 3 seconds and it doesn't happen, then it'll be. And of course, our continuous integration has or had until recently anyway, Raspberry Pi 1 devices, Pi 0 devices, in fact, until this year. And those things are resource constrained, by design. And I would go in and I would remove the set timeout and change it to let's just say the easiest thing to do when this works is to use process.on and listen for the exit listener. So in case that happened, and people who have been on the project forever would be I don't know, if it doesn't happen inside of 3 seconds, then there's probably something else going on that's a problem. Yeah, so you're running it on a Pi 0. The other thing is one of our hosts in continuous integration has 64 logical cores or something, and that's how the tests that get run in parallel in the test suite. That's how it counts how many logical cores are there, and then that's how many tests it runs at one time. I don't know why that machine thinks it has all that CPU. It doesn't. And so, it just tries to run way too many tests. But the test should not, fail when that happens. The test runner should time out, as I mentioned in the talk. And so, so set timeout, with some magic number is totally the thing that is there everywhere all the time. So that was a really, really long way to say long timeout.
Gotcha. All right.
Any other really, really brief yes/no questions I can answer with 40 minutes of monologuing?
I don't know. Sorry.
I have a question for you.
You have a question for
fun
me.
Dinosaur fact. Why do museums have all these old dinosaur bones?
Because aren't most of the bones in most museums are not real?
You just
They're-
humor me here, will you?
Why? Wait. So wait. Question was
Why
why?
do museums have old dinosaur bones? Because they can't afford new ones. Thank you. Good night.